I just want to address some few words about this panel. And as someone involved in the organization, I have to say that this is good to see that this panel is very representative of what we try to do for each of the panels, to have a balance that is not only a gender balance, it's a geographic balance, and it's a balance between academics, corporations, and policymakers. So you have a bit of everything we look for in when we're thinking each of the panels for CPDP. I can remember from last year we had a panel on cars, but based more focused on location, privacy, and you see from the presentations how this is developing really quickly, the amount of information that you can collect from cars, and all the issues related to especially privacy regulation and so on. I'll present you, I have 5 speakers, so I'll already say that I need to be a bit strict with timing, that will be speaking for maximum of 10 minutes each. We have Isabelle Chatelier from the EDPS, Hania from TomTom, Brigitte Lonc from Renault, Maurice Schellekens from Tilburg University, from Tilt, Panagiotis Papadimitratos from the Royal Institute of Technology in Sweden. And as our moderator, we have Wout van Wijk from Huawei. So I will immediately pass to our first presenter from Tilt University.
That will be me. My name is Maurice Schellekens. I'm a senior researcher at the Tilburg Institute for Law, Technology and Society, and I'm specializing in robotics and especially robotic cars. So I hope to give a short introduction to put things on the page for you, and to look at some threats that may be overlooked. When you go to a privacy conference, you first think about, and you think about the problem of interconnected cars, you immediately start to think about all the data that are being collected. And the amount of data that is being collected is astounding, because every mechanical component in the car is controlled by what's called an ECU, as an electronic control unit. They're all linked up together through buses, CAN buses, so they can talk to each other. And an enormous amount of data is being collected, not just about the car. We've seen that for a long time, for instance, the rotational speed of the wheels, or data about the driver and the passengers, for instance, a rough indication of the weight of a passenger for adequate airbag deployment. We know what the destination is because of the sat-nav. We know what kind of entertainment has been chosen. That's all in data that are being sent around in the car. But what's new is the interconnected aspect. So the car starts communicating with the outside world. But not just that, the car also starts collecting data, not just about the car itself and its inhabitants, its passengers, but also from other traffic participants. We've all heard about the self-driving car, which has all kinds of sensors that look outside the car at other traffic participants and collect data about them as well. Now, much of this sharing of data happens on the basis of some form of consent. So the manufacturer of the car will collect data. The manufacturer of navigation equipment will collect data. The road manager may collect data because the car talks to the road as well, perhaps the lease company, the employer. And if you think about all these data that are being shared, this is not just done because it's handy, but it also ties in with all kind of governmental policies. We do want less traffic jams. We have environmental concerns. If you want to realize that, then maybe cars have to drive in platoons. And if cars drive in platoons, then of course cars have to communicate with the outside world. And this element of communication with the outside world, that is something new, which gives rise to new and unexpected consequences. You see these two guys here. They are hackers, two American hackers, and last summer they announced that they succeeded hacking into a car, because a car, in that case a Jeep Cherokee I believe, communicated with the outside world via the mobile telephone network. So this capacity to communicate via the telephone network makes it possible, in principle, to hack a car from a distance. In the past, if you wanted to hack a car, you had to have physical access to the OBD, the onboard diagnostic socket. But I won't bother you with these details, but now it's possible to access cars from a distance, and if it goes via the mobile network, that can be any distance. Such a hack can lead to a data loss. Think of the Articles 30 to 32 of the General Data Protection Regulation that's coming about. That raises concerns, but what perhaps raises even more concerns is that hackers, through the interconnectivity, may be able to control a car. These two hackers demonstrated that they took control over the transmission, over the windscreen wipers, etc., while somebody, a volunteer, was driving the car on the public road. So it's showing that this is in principle possible. And the question, of course, or this raises the question, should we regulate about this? And if we regulate, then one of the questions that you quickly come across is, do manufacturers do enough? Of course, there's little known about this. I found this report made by an American senator. I'm not going to say this is the pinnacle of academic research and that this is the final word on it, but it's a survey that has been done, and it might give some indications. Some of the indications that we get from this report is that the 16 manufacturers surveyed had cars that almost all of them used wireless connectivity. Most manufacturers didn't register past hacking attempts. Countermeasures that manufacturers took against hacks were inconsistent and haphazard. That's what they found. And only 2 manufacturers in their 16 manufacturer survey described meaningful diagnostic and response capabilities against hacking attempts. They also looked at the more, so this is more the physical cybersecurity side of it. They also looked at the data side of it. They found that manufacturers collect large amounts of data that are wirelessly transmitted to data centers. Both data centers owned by the manufacturers and data centers owned by third parties. The personal data were presented, or the collection of data was presented to the customers as necessary to improve the customer experience, or these kind of formulations, however broad they are. And customers were not always made aware explicitly aware of these data collections, and if customers wanted to turn them off, they tended to lose important functionalities like the sat-nav. So this is an American research. Maybe things in Europe are different. Maybe we'll hear about this from the other participants in this panel. But usually cars are made for both the European and the US market, so perhaps these findings have relevance for Europe as well. At least there is a case to talk about. So this is a bit of an overview. We've gone from collection to data to hacking to the idea that maybe something needs to be done to be regulated in order to protect the data, protect cars against hacking attempts. There is, I think, no specific legislation. We do have for cars legislation on type approval, but these tends to regulate more safety kind of issues, not so much security kind of issues. Not completely true. The type approval rules say something about locks in car, etc. So there are small inroads into security, but nothing comprehensive when you look at the interconnectivity that's starting to happen. What's also interesting is that if you think about regulation and about protecting cars, let's say it like that, against hacks, that you come into contact with different fields of law, at least fields of law that are not familiar for car manufacturers, as far as I know. You think about computer crime legislation. You can think about the draft Network and Information Security Directive that's coming about. That's about market operators. Well, is a car manufacturer a market operator under this directive? Many questions here. Of course, the new or general data protection regulation says something about how you should secure data. In national laws, there are all kinds of existing duties of care and due diligence, which are not consistent or very well elaborated. So if you think about regulation of this, a lot of things are on the table and need further research. In the US, the senator who did the survey tabled a bill, the so-called spy car bill, which on a high level creates some specific rules for security and data protection in interconnected cars. Many of those rules still need elaboration by lower bodies. Will be interesting to follow that. The question is, what will we do in Europe? Do we something? Do we need special rules? Are the general rules that we have sufficient? A lot of questions to be answered. I hope I have given you, in this very short time frame, a useful overview. And if not, I'm happy to take any questions at any moment that the President will allow. Thank you.
Thank you, Maurice. You asked two questions, one for manufacturers in terms of risk, any more questions for policymakers in terms of regulation. Fortunately, you have both on the table, so maybe you have the opportunity to discuss that. I'd like to pass the microphone to Hania from TomTom.
Thank you. So my name is Hania. At TomTom, I'm heading up our efforts in the space of privacy and security. It's something we've combined. You probably know TomTom for the navigation device that potentially saved your marriage. That's how we like to think of it. And actually, but we've moved beyond that. So we're nowadays a mapping company. We do vehicle telematics, and we're also in the space of automotive, in which many automotive companies take the components. We also package up in our consumer devices. So consumer play, business play. And the course of that, we indeed have access to a lot of data. And connected cars aren't new. They are in Europe on the road, at least that I know of, since 2009 when we introduced them. So it's not like it's new. There's millions around there already. But it's changing because we're on a path, we as TomTom, towards automated driving, autonomous driving. And that requires new maps. High definition, highly accurate maps, which until now were only generated once every 3 months by us, by here, our competitor, and similarly with Google. And then they need to be distributed. And that could take 3 to 6 months or even longer. And that's not acceptable in the course of automated driving or autonomous driving. You need fresh maps every day. And in order to do that, we need to reinvent map making. That's what we've done. But we also need to gobble up even more data to get the changes on the road into the system for the people who will drive the same route next day to have the freshest map. So more and more data is being used. And basically Maurice alluded already to that. A lot of his data is indeed to improve products and services that you use. So there's a direct connection between the product and service that you use and the data being used. We also have a business model in which we sell what we deliver to you for money. So a very old-fashioned, single, direct, single-sided business model. And there's a watershed, because there's also companies that have a other business model. A business model which is a two-sided model. You get a great service for free, and then you know your data will be used to monetize with others, and maybe you get advertising or other stuff. That's a key differentiator. If you look at many of, like us, or automotive companies in Europe, they are very much in single-sided business models. And there's actually, you could see 2 reasons for that in automotive space, at least that I see. Number one, which is very often overlooked, an existing regulation that we have for a couple of years now, which is also known as cookie law. Cookie law is the e-privacy directive, which says if you pull data from a device connected to a telecom connection or any network connection, that's a car on this connected network, if you pull that data, it either has to be technically necessary or strictly necessary for a service delivered to you, the user, the driver, or otherwise we need consent. Now, consent in a car is not an easy thing to do, combined with purposes and a lot, and the driver is changing, and that's the data subject, the user. Mind you, the e-privacy directive is not about personal data, it's about any data. So this has been put into regulation, and many car manufacturers and companies like us know this, and there's fines attached. So it's very difficult to come up with other two-sided business models and stick to the law. Now the next question is, will it be enforced? But that's the law. And we tend to be European technology companies very well aware of the European norms. So any thinking of, this data will go everywhere and it's uncontrolled. No, the automotive companies I work with, their privacy officers, they are very strict on this. They may not be completely in time, and GDPR with data privacy by design will help them to establish their role, but it is not like, oh my God, my data is going everywhere to the insurance company, to the advertising company, wherever. It's not really happening. It is delivered for you as a service, and if not, they have to tell you, and you can get your enforcement action in place. There will be a max Schrems on cars, no doubt. So, not to worry too much about what's happening, in my view, because I see it happening, we build that stuff. Now, there's another reason why it's very difficult to have a two-sided business model, because the two-sided business model thrives on getting your attention to the advert, to the pop-up, to the message. That's a safety hazard in a car. There is regulations related to driver distraction, and it's a key topic at the European level. That is incompatible with in-car ad business models. Now then, when we move to autonomous cars, we will get there. So autonomous cars will mean indeed that you will be a passenger in your little home with where you can be distracted. So this is why there's also kind of a watershed for several reasons between those who advocate the fully autonomous cars and those, which kind of is the European industry, taking it step by step. Also because there's a lot of other stuff already out there. One of the elements in there, and Maurice already alluded to that, is new forms of communication. So that's what in our jargon is called Cooperative Intelligent Transport Systems, C-ITS. Cars who start to broadcast information about where they are, where they're going, how fast they're driving, for others to build up a picture of the world around them, also around the corner, which means that the car will have safety features to warn you, or as the next step, to stop or decelerate if hazardous events are there. There's also mechanisms to tell you that the next around the corner it's slippery. These cars start exchanging information. Now, getting back to the regulatory stuff. There is a report which is free for download on the DG Connect side on a program we've run with European companies, road authorities, regulators, even a few legislators, regarding how will we deal with this topic. And one of the topics in this has been privacy. And it's been very well recognized that we need to work on this. We've also come up with ways to foster this and further this in recommendations. So it is on the radar screen and it's going into action. And European Commission is currently contemplating on what the next steps will be, but it's clear there will be next steps. One of the contentious topics here is how do we gain access to this in-vehicle data in a properly controlled way? Because it's also required for the road operators, so governments. So that's kind of an interesting topic. I also want to point you to one other thing that recently happened. As you probably know, as of April of 2018, every new car will have a capability to automatically call 112 when you're in a crash. It's called eCall. This is a law, so it is mandated. In privacy legislation, I don't know exactly, but it is a legal requirement for the processing of personal data. That has forced the legislator, who it kind of is the controller now of that data, to be very specific on the implementation. A lot of work has gone in there, which is a great model for how you can do stuff in car space in a privacy-friendly and correct way. And there's actually a regulation which dictates the requirements for type approval of vehicles with 112. If you read it, you will have privacy by design. So, to summarize, do we need more regulation? I don't believe so. I think there's a lot of regulation that's already out there that we just need to apply in a proper way. Thank you.
Thank you very much, Simon, for your presentation. Let's move. Yep. To Brigitte Lonc from Renault.
Okay, thank you for inviting me to this panel. So I wanted to give you a survey presentation of the connected vehicle ecosystem, looking at the present situation and the next steps. I probably will repeat a little bit what my previous speaker has already presented, but please forgive me for that. Please, next, or shall I do it myself? Okay. Okay, so for the connectivity systems and services, they were initially introduced about 10 to 15 years ago with the first integrated navigation systems. So this was in years 2000, 2004, with, for instance, Renault launched the Carminat navigation product. And there you get real-time traffic information via radio communication, RDS-TMC, and also with the Bluetooth connection to the smartphone, the driver was able to enable mobile phone communication. So this, since this emerging system, there has been a lot of new technology communication technology developed, like the 2G, 3G cellular networks, and also these new displays used in the car and now integrated in the dashboard with controls to the drivers, allow to bring more services available to the drivers. So, for instance, the next generation, where the Carminat TomTom Live, basically with our equipment supplier TomTom. So this system, this was providing a low-cost, cost-affordable navigation system, and also using the 2G edge communication, some live traffic services to bring to the driver in the car. Then the next steps in Renault was the development of the Airlink system. Airlink is a tablet installed in the car, and which is connected to services via Renault automobile service platform, and this allow to get services to support the driving, or for vehicle-related services for the drivers, as well as also to download some apps for more, for having more digital information and entertainment services like the music in the car. Then this was, of course, there is some, of course, some evolution of this system where we deliver more possibility to get apps in the car delivered to the drivers, which can be either free or paying apps, and this has the current evolution. As you see, this now connectivity system are well established and are expanding very quickly, which allow new services provided to the drivers, and will be even more accelerated in the next future. With connected vehicle, but also with smarter vehicle like the autonomous cars, as was already mentioned too. So the next future systems in the navigation domain, this will be this, for instance, the coming of VPA, the virtual personal assistant, in the car, installed in the car, which now the drivers and customers are demanding very, very highly. And this VPA tool is bringing more services for the drivers to help him in driving, in planning the journey, to get this personalized entertainment and digital information in the car, and also basically to access to more mobility services. So this is an important tool, and the evolution of this tool is also going into more intelligent, with intelligent agent and proactive services, where we want to provide personalized service and answers to the preferred services to the driver, And for doing so, of course, we need to collect more information and get more information on the drivers. What is his habits, what he likes, what is prefer music, what is his family life or business activities, and so on. And this will be done in connection with the cloud services and large data banks. So basically, if we want to give more proactive, personalized service, we need to have access to personal information, which can be seen as sensitive private information, even from going in a little bit in your intimacy, or for certain person, depending on the feelings, could be considered, of course, as privacy, highly privacy information. So this is something that is being worked and looked in the research domain. So we know, of course, in Renault, we want to keep the confidence of the customers, and we know, of course, that this is very important, that the users is having control to his own information and knows clearly which service provider is processing this data. Of course, this cannot be done without developing some technical protecting solution, such as pets or privacy preserving techniques in this system. So the vehicle, of course, is becoming integral part of Internet of Things, as is, of course, is evolving and cooperating more and more with its environment, like the smart cities, smart home, but also communicating with the road, with the traffic signs, traffic systems, etc. And okay, so please. It's done.
Oh, okay.
Thanks a lot. So this is the full picture and topics of connectivity system in the vehicle as we delivered today. On the upper side of the picture, you have all these navigation techniques which are used in navigation, we are using the localization system like GPS. We are bringing real-time traffic information via digital radio, and also providing improved traffic services via service provider and connection to the to Renault service platforms, and this information is provided via 2G, 3G communication. On the right part on the picture, you see that's also we have the ability to integrate the smartphone, and therefore brings the drivers social apps and all this new application for also for the user's life in his car. And the last part of the slide is presented the next future communication systems, which has already been presented, which is a car-to-car and car-to-infrastructure communication. So this is the new challenge of cooperating between car and other car and environment to provide the vehicle dynamic information and the driving information to other parties of the road, other vehicle or roadside equipments, for instance. This is typically using wireless communication, which is called Wi-Fi P over ITS J5, and this Wi-Fi is similar to Wi-Fi technology with longer range communications up to 700 meters and adapted for mobility.
I have to ask you to jump to the conclusions.
Yes. Of course, this will allow to deliver, as we already said, improve the safety applications and reduce the traffic congestion and allow smarter mobility. And I think the picture there is not bringing any new information. Again, this was already presented. So the interesting technology is that we are able to give real-time traffic events, road hazards can be detected and broadcasted to other cars, and they will be the base for to develop safety applications to avoid collision, etc. And this is paving the way for the autonomous vehicle. So as already mentioned, the Commission has delivered last week the CITS final reports, and they are preparing the next steps for deployment of the technology in Europe, starting from 2019. This will be my conclusion. Or my colleagues, I think Panos will give you more explanation on the security and privacy techniques which are developed for this kind of communication.
Thank you very much, Brigitte. I would like to invite then Panagiotis.
Right. So yeah, so for simplicity, you can call me Panos. It's like a, I don't know, a convenient nickname. So I'm a university professor. I don't have any slides, so I'm fine. I'm a university professor at in Sweden, in Stockholm, a technical university, the Royal Technical Institute. And I've been primarily working on security and privacy, emphasis on mobile computing. And in that area, all of a sudden we get to realize, when we know about platforms of this kind, or even small embedded ones, that the vehicles are becoming the mobile computing platform, in the sense that you have multiple radios, you have practically no power constraints, and the ones that you see in embedded platforms like sensor nodes, etc. You have multiple applications, very clear ones focusing on transportation, as long as along with those a number of infotainment or user-centric applications, right? So all of a sudden, this not only generates a dynamic of its own, but all of a sudden it creates new constraints and new opportunities, let's say from the strictly technical point of view. And there has been a lot of research on security and privacy. The two go together, or they should always go together. Focusing on what you would call, when you refer to these collaborative intelligent transportation systems, to vehicular communication systems in a broader sense. And I'm pretty happy that my groups over the years have been at the real forefront of the security and privacy research for this topic. And I see some familiar faces here at the front from collaborators from the first phase, and of course Brigitte from the second phase of this effort. And essentially, there has been, then since I see Antonio there, I'll say, he was talking about the, how would you call it, the baseline and future-proof solution, some years ago. So essentially, there has been a consensus between, or some sort of grown understanding between industry and academia. And academia has always been pushing forward, fancier and more elaborate solutions, but at the same time, the industry has been accepting, let's say, the simpler ones. Anyways, to the point that few months ago, someone complained or told my face, I won't say from which major, let's say, company, said that, oh, you guys in the vehicular context, you lost the last 20 years of, progress in crypto. And of course, I scoffed at this, and I explained to him very politely why the specific choices were made. Anyway, to make a long story short, there has been a lot of progress on how you handle credentials and identities, and how you manage essentially security. You build this infrastructure of security, how you secure the communication protocols, how you put emphasis on making them efficient exactly because you have constraints, and then how do you do some minimal checking on the consistency of this data, and then how do you handle the hardware that you have on board for protecting the data that the car carries, as well as making the necessary more expensive computations. So this more or less is the picture. I didn't prepare slides that would be, very academic or kind of telling you what are the specifics of the solutions, but rather I will jump to 3 or 4 points that I think we should put our attention in the coming years and try to conclude with a couple of, let's say, take-home messages. So what is happening is that there's a convergence with the traditional internet. Beyond the Internet of Things that Brigitte mentioned, there has been a lot of work on the what you call now the web, right? And all of a sudden, the cars are no longer in a different sphere, in a different bubble of their own. So we have to really pay attention to what is actually happening in this conjunction, or where the two worlds meet. How do you do identification? How do you do authentication? How do you take care of privacy matters when you are actually running applications which exist on the web, but you are in a vehicle? And then this is not a pretty easy answer to give, exactly because there has been some sort of different path in developing security and privacy solutions, let's say, in vitro, or from a different starting point from the vehicular communication side. Second major topic that we have to pay attention is does it really mean privacy, or how do we, to put it differently, because this question was too broad, how do we quantify privacy? Because it's not only the semantic or the abstract way of basically just removing identities, but is through what type of data or which richness of data, or even timing of operations that someone could trace a mobile user, a vehicle, and that has to be catered and be precise. Otherwise, we'll be kind of going around in circles. Third major point is how do we collect actually in a way that is technically enforcing privacy and security at the same time, never one without the other, the collection of data, which can be, again, useful for smart cities and other realms beyond the vehicular communication domain. How do you disconnect, for example, when and where something happens from who does it, or what did this entity did before and will do after? And how do you make sure that the whole infrastructure that you have in place ensures that this happens? And this connects immediately to the next point. Having this wealth of data, what one has to decide what is actually the the adversarial terrain. And we do think of bad guys or Mr. Evil that would like to do all the worst, let's say, with our systems, or trap our users. But here we have to make another step, a leap forward, if you wish, and make sure that we address yet another class of adversarial, in some sense, behavior. We should pay attention to entities which are honest but curious, meaning that you are a service provider, you are even an infrastructure that enables a whole system to be deployed, and there you have a wealth of data in your hands, and of course people trust you, or you are not exhibiting any malicious behavior, but you do have this wealth of data, which could be a treasure down the road. So how do we make sure as community, as societies, that we don't all of a sudden abandon such treasures or such temptations, let's say, towards connecting dots and putting 2 and 2 together, to those who do have this huge access of data? And then this is a technical challenge and a legal challenge as well. But I'm always talking from the point of view of technology. So what is my take-home message here is that we should make sure, and we do have the technical means, we do have the knowledge, and we can, of course, refine the technical means down the road to ensure that these systems, these vehicular communication systems, that's the term I'm using, but you understand what I mean, and it connects to what the previous speakers are using, are trustworthy from both points of view, from the security and the privacy point of view, because if we deploy all these cool or super productive applications of all sorts, but at the same time we open the door to all sorts of abuse, then we are not doing ourselves a favor. We might eventually face situations where this technology, no matter how much it's catching on, could be discredited, and loss of the confidence of your clients is one, but then it might be even worse. So what I'm saying here is that let's make sure that we employ the technical means, the technical expertise we have in our hands, and make these systems trustworthy a priori, and then make sure that what we know and we can precisely specify as requirements and what the systems achieve match and is juxtaposed in a precise way to what are the legal requirements that the legal experts can put forward. And that would be, let's say, my ideal world as a researcher, as a citizen. And that's it. Thank you.
Thank you very much, Panos. So we move to our final speaker, Isabelle Chatelier from EDPS.
Yes, so I will try to be shorter, because actually a lot of the precedent panelists, they have already touched on a lot of things that I wanted to talk to you. But one thing I wanted to say is why the EDPS is dealing with connected cars. Well, actually, in EDPS we have a role of advising the EU legislator on new legislation that impacts on data protection and privacy. And there have been quite a few texts produced by the EU legislator regarding transport in the past few years. One major one was the Intelligent Transport System Directive that was adopted in 2010, and which leads to more ongoing work, because it provides for a number of actions to be taken again by the Commission through delegated regulations. And a few of them have been adopted, others are in the pipeline. And these delegated regulations are trying to fix some kind of standards for exchange of information with respect to different aspects of road transport. So, for example, to facilitate road safety, what kind of information could be exchanged between private operators and public authorities, so facilitating this exchange of information between them. There are also projects to do such thing on real-time traffic information. There was also a delegated act on facilitating information sharing about parking places. So there are quite a number of actions, and the aim is really to try to set certain good practices as to what are the data that are needed to do that, try to limit the data to what actually is necessary, and try to agree also on some common standards for exchanging this information. We've also been advising on this equal type approval regulation that has been mentioned, to try to make sure that there were the necessary privacy and data protection safeguards into this regulation. And we've also advised the Commission in this working group that was mentioned on the intelligent transport system and cooperative systems. So what connected cars bring, and all these intelligent systems bring, as was mentioned before, is this interconnection, this becoming part of the Internet of Things, and of course the legal framework that is in place for data protection applies to that, but it poses a lot of quite challenging questions as to how you can ensure compliance with certain of its components. And I will just mention a few of them. For example, in a lot of this legislation that we have advised on, we've always consistently recommended to, as much as possible, use anonymization of data, that when you don't need the data to be actually identified or identifiable, it would be better to anonymize them. But of course, if you put that in a context of Internet of Things and getting a lot more of data, and as was mentioned by my colleague next to me, at what point, what amount of information do you collect that will actually allow you to indirectly re-identify a person? So this question of anonymization in the context of Internet of Things is obviously a major challenge, and usually we try to look at it by recommending data minimization to the maximum extent. The issue of security was already mentioned, so I won't go into the details, but of course, yes, the regulation, the GDPR, does set certain criteria. There will be also the new data breach reporting obligations that will enter into force with the GDPR, so that any breach of security will have to be reported to the competent authorities and might lead to enforcement actions. So we also need to be prepared for that. One aspect also that can be challenging is also how to ensure transparency, respect of individual's choice, providing the right amount of information to the person, allowing the person to form a choice about also specific features about the product. For example, if you use location tracking, well, if the person would like to opt out from that and it's not necessary for the service, then this is something you should consider as to the granularity of the choices that the person can make. And to go out with that, this is what we would usually recommend also, is to use all these privacy by design, by default, all these privacy enhancing techniques and technologies to have a better choice and control over the data. Another challenge can be also the question of data quality. When data are interconnected, collected from different sources, how do you ensure that all along the line the quality of the data is already maintained, that they are up to date, and that inaccuracies are actually being addressed and signaled throughout the chain? That is also something to think about. Of course, also the question of secondary use and is also quite a major issue to look at, the repurposing of the data, and needs appropriate safeguard. And I just would like also to mention that with respect to, we haven't mentioned the individuals very much from the individual's perspective here, but of course there are a lot of rights also, to right to have access to their data, to know about what data is processed about them. And the GDPR will also introduce this new right, this data portability, that if they want to move the data with them to another service provider, they should be able to do that. So that also needs to be considered as to how this can be actually implemented. And so to finish off, I would just say that yes, there are many challenges, but well, there is also some guidance. For example, the Article 29 Working Party issued in 2014 an interesting opinion on the challenges of the Internet of Things. So it's not specifically about cars, but there are a lot of aspects of the connected cars that actually fit within that, and they have a lot of good recommendations. And yes, to look ahead also for the GDPR, and certain principles, for example, the principle of accountability will require all data controllers to actually make sure that they put the right safeguards in place, that they appropriately document them as well in case of further enforcement actions by the data protection authorities.
Thank you, Isabelle. We've now had all panelists do their talk. Can I see a show of hands, please? Who has questions? I see two. You, sir, first. Could you please identify yourself and ask your question and identify to who?
From Datenschutzraum. My question is, you said you make the systems secure. The question is, the lifetime of a car can be longer than the warranty. And of course, the vendor wants to sell a car every year, but some people want to drive a car for longer. And if the car is 20 years old and you find out there's a security breach, you cannot update the firmware. Who pays for the hardware exchange? What must be done in such cases? or do you even think about long-term solutions for these issues? It must not be 20 years. It can happen every day. So you don't know, and it actually affects most or all cars of the same type at the same moment. So how fast can this be distributed?
Thank you. Is there anyone who would like to address that? Brigitte, you, for instance, from a car manufacturer's perspective?
There is many questions in a single question. So, for the Car2X communication, which is a new technology, as we are exchanging many information it must be trusted between many car makers. There have been a lot of discussion, especially with the Commission, about the crypto agility and the perennity or erosion of our security systems in the cars, which started some work and reflections there for how to update and how to react if the security of the system is breached. And of course, during the lifetime of the car, we need to be cautious or be able to do that. This is, of course, a lot of the solutions are being looked and in the research. We are also starting to look on the software update over the air with the communication networks. But then that depends a lot of the manufacturers, and there is many different point of view in the car manufacturer markets, and there is not a unique solution, I guess, for all OEMs. But we are looking that to be a little bit more rapid, more quick, and that, of course, if there is security problems, we always have the possibility to recall the cars, which of course we are trying to prevent as far as possible. So again, this depends a lot of OEMs' perspective today, and as you mentioned, I guess there will be some financial impact on the customer finally, because if you want to have the updates in a very reactive way, it's cost. It has cost, and the customer on the car will have to pay some cost somewhere. So,
okay. Thank you. Panos?
Right. So let me start from the term you used, the long-term solution. So when you design a security or privacy solution, let's say security, since you start with that term, essentially you want to be rigorous. You have a clear specification. You say, what are you trying to do? You say, who's the bad guy, who's the adversary? And then you design the solution, and then you argue crisply, rigorously, and even formally, if you can, that your design satisfies the requirements, right? So in that sense, this is the longest term possible that you can get. If you do this right, then you are in great shape. There's a difference, though. Such designs could be at a distance from the implementation itself, right? And there are many implementation mistakes, these which could software implementation issues, which could lead to what we usually call hacks, right? That's more or less it. There, of course, it has to maybe some sort of risk kind of management decision, and then there should be a decision on how much investment should go in it. But the solutions can be long term. What Brigitte talked about is crypto agility. It has to do with the nature of the building blocks of security we use. We use cryptography, which relies on computational complexity assumptions. It basically says that some math are very hard to be done. Thus, if you are an adversary, it would take you not eons, but I don't know, decades to break my key. Yeah, this can also be projected. This projection, though, would come with some monetary cost, because then you'll have to predict. You have to decide, let's say, how much money you want to pay for the hardware that do these computations, which go up as the key size go up. So even that could be predicted. There could be a rule of thumb. And now, if you do this homework correctly, and of course, you make sure that your software engineers are trained as they should, and they're not rushed, and they use all the appropriate techniques, etc., then we get into your question, who pays for the case of some sort of fundamental upgrade, let's say, of the vehicle, which means, for example, you have now to get rid of an onboard unit because some major faults have been found or some new. So then this could also could depend on regulation. For example, would your car be no longer able to circulate at all if you don't do the upgrade? The equivalent of not having a catalyst, let's say, for your, you are kind of an environmental danger. Well, if so, then there might be two issues. Like either you as an individual, you decide to sell it, scrap it, and then the car will circulate probably in a different continent. Or, who knows, I mean, maybe the car manufacturers will come up with some sort of plan to offer you a package to say, buy the car, and if such an event happens, we will, I don't know, retrofit it and fix it for you, and then you just take out. It's just a box after all. It might be a tiny box in your trunk somewhere, so it's not such a big deal after all. It's like changing your engine, and it could happen. So I'm saying all this to say that if the work is done correctly, I would feel quite comfortable that these things could be taken care of. After all, when it comes to security, the life cycle and then the rate of change is much slower. So we have to deal with systems. We build systems which are updated, constantly.
Maurice, you have anything to add?
Yeah. I think if you look at this from a regulatory perspective, it's not your own safety and security alone that you are talking about. If you are driving around in a car that's vulnerable and maybe vulnerable to some hacks or etc., that may cause also problems for other people. So I think from this perspective, there is a reason to say, well, we can defend that the user of the car or the owner of the car incurs some costs if it's really necessary to replace a hardware or firmware part, etc. That said, I don't think that solves all the problems. If you look, for instance, at Microsoft, they stopped their support of Windows XP in, I believe, April 2014 because, well, it's no longer an operating system that's used enough, so it's no longer profitable to Microsoft. Yeah, that could be a problem if the manufacturer is going to say, well, this car is so in current, there are so few cars of this type left, we're not going to do that, then you might have a problem. But that also depends on to what extent it would be possible to disconnect the car, so to take away all connectivity again. So indeed, it's a difficult issue.
So it becomes a hazard to drive an old-timer, basically. Yeah. Can I, Simon?
No,
Yeah.
Can I just add one other thing, because we're talking about remote miscreants hacking into my car. What you also have to realize, we talked about secondary use, there's also a tertiary use, which is laws that allow police officers to remotely enter into automated systems. They're meant to do stuff with terrorists and child pornography, but there's actually laws in Belgium, but it's coming up in the Netherlands, in which the police will have the right to use technical vulnerabilities to go into your car and make it stop. Well, they won't do your car, they will take the car, of course, of a suspect, which could coincidentally be driving next to you, and it's actually talk to the police officer. This is what they want. They want to have the opportunity, the capability to have these cars stopped, even when using technical vulnerabilities. So, to reverse that, to us in the industry, that creates a new threat that we have to take into consideration to protect you as a driver, actually, to make sure that the police can't get in. So, strangely enough, it also triggers another element. But these laws are coming up, regulations.
Okay, thank you. There was another gentleman standing up. Yeah. And then. Okay, quickly.
It was said that I was involved in this project, and 4 years ago we had a workshop, a computing workshop, where Caspar Bowden was there in Berlin, and precisely on this he criticized us so much. He said, "But you are building a surveillance by design system." Okay. At the end of the session, he told me, "Okay, apology, Antonio. I didn't mean to hurt you, but this is really what you're doing." And this is exactly the issue that we have to take into account. That's what I wanted to.
Okay, thank you, gentleman over there. And then
this is a very weird. Feels like I'm walking to an idol's stage. I had some very short questions. First, to Isabelle, you said privacy by design is when you are able to opt out. I think it should be the other way around. You standardly opt out, and maybe you should opt in. But I was also curious about, you all have this kind of techno-deterministic dreams that all these cars will be there and everybody would want them. I would be very curious in how you respond to either two trends, and one is, are these self-driving cars built in so that is there a functionality that I can break the law and speed if I want to, or not? And the other trend is, if there is indeed a self-driving car that automatically regulates driving, etc., then it will be highly unlikely that I will own actually a car, right? That would be very unlikely. So how would you deal with that in terms of data protection? Whose data is it then if I take passengers, etc.? So the first thing is, and there's the third thing actually is, what do you do with people who refuse to go with this trend and keep their old cars and become another secondary type of driver on the road next to these self-driving cars?
Okay, thank you. There was another question there. I would like to take them together because of time constraints. Go ahead.
I'll quickly throw two things that you can answer very quickly. Will the right of portability and some of the standards that are geared at making it easy for consumers, or third-party services that consumers want to plug in, create some security risks once we're opening the door? Will the hacker or the scammer trick me to give away my data, number one? And number two, who will decide which algorithm is used to prioritize the driver's life over this person's life, over that? Will companies be saying, well, my algorithm is the best, it always protects you, it only kills other people, or no, I only kill poor people, rich people? There are ethical decisions that some algorithm is going to have to make. Should government do this? Should companies? Do we need an ethics institute that will say, look, this is how we are making these decisions. You, the human, are not making a better decision, so we're going to reflect the best morality we can.
Okay, thank you. Isabelle, can I ask you to go first on this?
Yes. So yes, sorry, I think I went too fast when I talked about the privacy by design and by default, because all I meant was to say that it needs to be properly designed so that actually there is actually control by the user about the data. And sorry if I went too fast in explaining myself. With respect to your question on the question of choice, I'm not sure I understood completely, but the thing is, for example, if it comes to a mandatory system, like we have, for example, with the eCall, that is now is going to be a requirement that it is embedded into the car, and this is exactly why we were involved in the legislation, because we wanted to ensure that if something becomes mandatory, then there are the proper safeguards for the individuals, and so if they don't have a choice, at least we want to try to make the processing as less intrusive as possible for them. So, for example, that's where we required a lot of anonymization, certain limits on the retention of the data, also certain limits about the reuse of the data, who are the recipients of the data. So if it came to a point where certain cars would be out there as with some mandatory features, this is where we would ask the legislator to actually take into account those data protection components, to add them in these mandatory aspects, so that it compensates for the lack of choice, as you say, of the person over the design of the equipment.
Okay, thank you. Panos?
Well, there were like amazingly interesting points. All that I will try to just touch here and there. But again, so very quickly, so I suppose there might be a shift in the model of car usage. So we might not own cars in the near future. We might just start hopping on and off on them, automated or not. I mean, probably automated. So there might be totally new landscape there on how you handle data. well, when it comes to, I don't know, driving aficionados, etc., well, I don't know. I would be one of them, but I don't know how I will survive. So. Yes, actually, yes, you could be. I mean, I saw a neighbor of mine has an old Porsche with stickers, whatever. He drives it in Germany in a specific circuit. That's it. Now, when it comes to user applications that you plug in wherever, I mean, there has to be, from the security point of view, some very strict, I will use a term, I'm overloading this, firewalling of some sense, right? So there are safety critical operations which are critical for the vehicle itself. They should be absolutely untouchable, let's say, by those who shouldn't be putting their fingers there. And the rest, maybe, put whatever you want, and then eventually your entertainment system, let it crash if you don't do the right thing. I mean, that's all I care from the safety perspective. And the last thing about the algorithms and the safety, wow, that actually a game theoretic solution might be the only one we have, but that's a big discussion I would like to take up with you later on during the break.
Okay, so we had the bell. I will ask the three last panelists also to answer the questions if they like.
I can say something to the last one on the. What we need to also understand that is we will not have the end game of autonomous cars next year. So we have time to discuss and learn. It will go in phases and steps for the simple reason that there will be older cars, non-autonomous, non-automated vehicles for at least 20 years to come. They'll be there. And not all roads will be useful for autonomous driving. There are certain roads alongside cliffs that I do not want to be in an autonomous vehicle. So that's one. But on the other hand, if autonomous vehicles prove to be really safe, really avoid deaths and injuries, it may very well be that we come up with legislation for the good of us all, that on highways we will not allow people to no longer drive them for themselves. Could very well be. We don't know, depends on how good we get. On the ethics, we will have to discuss and learn, and for the first thing that these autonomous vehicles will have to do is incorporate the existing traffic regulations. Now, we don't know if they are very good with autonomous vehicles, because it could very well be that if autonomous vehicles and human-driven vehicles drive together on one road, that the autonomous vehicle grind to a halt to protect their drivers from the insane drivers behind them who are completely irresponsible algorithmically. We don't know. We have to discuss, keep track, step by step.
Thank you. And with that, I'd like to thank the panel for their input, for interesting points. Also, the audience for their questions and their interest and attention. And with that, I'll close the panel. Thank you very much.